Welcome to This Is My Architecture. My name is Yazid, and with me today is Tyler from Sentient. Tyler, tell us a little bit more about Sentient. What do you guys do?
Sentient is actually an AI research firm primarily, but I'm here to talk to you today about a product called Ascend, which is a UX optimization platform.
Great. So tell us a little bit more about this product and this technology. I see here that we have quite a bit of serverless infrastructure. Tell us a little more how, before we got here, how did it all start?
Sure. So Ascend is a multivariant testing platform that uses genetic algorithms to find the optimal combination of variations to a website to benefit a user. So we have customers right now that span the globe with visitors accessing it from everywhere from Australia to Asia to Europe and the US. We previously had an architecture using ECS with regionally distributed spokes, as we refer to them, which were clusters of ECS along with Redis clusters. That was really good to get us started, but as we got into more and more corners of the world, we found that it was getting harder and harder to get those regional spokes close enough to users to get low enough latency. So we set out to explore other options. And as part of that effort, we came across the edge lambdas, which were new when we were getting started, to solve this problem.
So tell me, if I were to be a user, right, making a request to a website of someone that's using your service, walk me through the flow. How does that work?
So the customer would have our snippet on their page, and that would be retrieved from CloudFront. So the script request would hit CloudFront here, which then has a generic URL, but that generic URL is backed by an edge lambda here, which performs the allocation of a candidate to that user. So it looks at things like their country, their language, device type, etc., to identify what experiment and specifically what candidate they're best suited for, and then rewrites the origin URL, which CloudFront then makes a request out to S3, retrieving a candidate that is returned to the user.
So tell me a little bit more about once S3 returns, right, to CloudFront, what happens then?
Exactly. So basically, the script is returned to the user's website. The website is then treated with the variants, and data collection begins. So to collect the data, rather than sending it all the way back to a regional spoke or something like that, what we do is we actually use another edge lambda. So the data is sent through CloudFront, which then hits an edge lambda that just immediately returns a very simple response. But that edge lambda actually writes it out to its CloudFront or its CloudWatch logs and immediately returns. So there's no delay in response to the user.
So how did this help you with latency? Did you realize some latency benefits by having everything pushed to the edge, all the compute?
Absolutely. So we cut latency by as much as 10x, which allows us to get onto the site and treated much faster, as well as having less of an impact on the customer's website.
Awesome. So CloudWatch, I see that you have CloudWatch in this particular phase, returning an event back to Lambda. What happens, are there any other events that happen in parallel from CloudWatch?
Yeah, absolutely. So the CloudWatch logs are then taken by way of kinesis, which initially copies them to S3, just in their raw form, allowing us to do any additional post-processing we want to do on them. But then it also sends them to a Lambda, which is responsible for normalizing the logs into the data structures that will be used within our system. That is then sent up to Elasticsearch, which is our primary store for the data coming out of the experiments.
And why Elasticsearch specifically?
So Elasticsearch is a really great data store for time series data specifically. It's also indexed, so it's easy for us to go and explore after the fact and for our data scientists to work with.
And I also see an ECS with a Helix logo on top. What's that all about?
Yeah, so we use ECS as the primary processing environment for our genetic algorithms. So ECS is responsible for pulling the data back from Elasticsearch and generating new candidates with each and generations that it then produces into S3.
So Tyler, when I look at this architecture, I think scale. What kind of scale are we talking about? Is this hundreds of thousands of users?
We're actually supporting millions of users per month with this architecture.
And looking further, Lambda scales, S3 does, CloudWatch. Is that the same reason why you chose ECS?
Yeah, ECS is a great platform when we need to do heavy compute. In this case, we're using it for our proprietary algorithms.
Great. So Taylor, thanks for stopping by.
Thank you.
Thank you for watching This Is My Architecture.